So team, welcome to the CICD, Continuous Integration and Continuous Deployment Live Training Orientation session. So today we're going to understand a few important topics like what is CICD and what are the different tools that we're going to learn as part of this and why we need to learn this fundamentally. Okay. So the basic assumption is that you all must be familiar with some sort of an automation. As of now, you would have done with some automation training, preferably Selenium WebDriver, right? So you may be a beginner, you may be still just started learning, or you have already learned the Selenium WebDriver and have fair understanding of almost all the topics like TestNG, most importantly, frameworks. So that's the assumption. But even if you're a beginner and started catching up, that is still fine. So till now, the industry expectation was that if somebody is really good in automation and if he is able to develop the frameworks, that's more than sufficient. But what is happening with all the engineering teams coming together, like the core development team, operations engineering team, quality engineering team, right? So they're all coming together, and another important aspect is the agile. So in which some of the companies have almost weekly deployments. In some companies, they have daily deployments. So when you have a frequency of deployments more and more frequently, like daily, it is not just possible to do manual way. So the question that naturally arises for the QA is that in spite of you developed an automation scripts, regression suits, like for example, you have 100 test cases, out of your 100, I'm just taking some random number. Let's say out of 100 test cases that you have for your application, you have automated close to 60 test cases, let's say. In a good framework, maybe like a keyword driven or a page object model, you develop the framework. But how you're going to kickstart this, how you're going to run these test cases, and what, so the natural question arises is like, how do we execute these test suite, right? That's first question. And what is the frequency? It's a very frequently asked question. So what is the frequency of executing these cases, executing test suites? So is it like weekly, monthly, or it could be like daily? So then how are you going to run it? If you're going to run it daily, is it like a manual way of execution? Then people will not really show interest because it's just impossible for everybody to stay late night and run it manually. So I'll put you a complete picture of how generally this from development to QA to UAT, how it works. Okay. And then we'll take a call, what is the frequency that we can execute it. So typically what happens in a project, so you will see, we're going to learn this tool also as part of the CICD program. Most of the companies will have a version control system. Most of the companies will have, or almost every company should have rather, because it's not possible to maintain the code locally. So we need to have a version control system. What is this version control system and what are some of those tools? I'll just explain. So when the developers write the code, let's say developer 1 is working on module 1, developer 2 is working on module 2, etc. But what can happen is that we have teams spread across the globe. Like we have some people working from US, some people working from India, and some from, let's say, Europe. So they all should be connected centrally. They all need to maintain the code centrally so that, when it comes to the enhancement of the code or addition of the code or modification of the code, they can take it from the central location. Like in our testing, we talked about some of the central tools like ALM, application lifecycle management tools. where you maintain the test cases, defects, test plan, etc. Right? Similarly, from a development point of view, the code needs to be maintained in a version control system. Some of the great examples are like we are going to talk about this tool anyway. Something like Git is a very popular version control system tool, which is an open source, and recently it bought over by Microsoft. Git or GitHub, that you might have heard about it. It's a very popular, version control tool. Before this, previously we used to have something like from Microsoft anyway. There is a tool called VSTS, or I would say, yeah, Visual Studio. It's a test suite, but Visual Studio also has a version control system. Before that, there were many tools like Perforce was one of the tool. During the VB time and all, people used to use something called Visual Source Safe, VSS. As the name you can see, source safe, your source code is going to be safely maintained. There was another popular tool called Source Depot. So all the names you can see, they start with something like, managing your source code. But in today's world, what we have majorly is a Git or GitHub, which I will be covering around 4 sessions as part of this CICD course. Because even the tester, after develop the automation code, that also needs to be centrally maintained, because you may have few testers working from US and few from India and few from Europe. So they also need to maintain the automation code, also needs to be maintained in a central location in a very secured way. The problem if you maintain it locally is that, suppose you write a source code in your local, and if you maintain a copy in your local, uh, many problems like other people cannot access your code. First point, maybe if you share the folder, then they will access. But again, there are a lot of other problems which are going to come, like what if your machine goes for a crash, so you won't be able to recover the code. All those problems will be there. Those will become the advantages or the basic needs of version control system. So if you maintain the source code centrally, it will have the copy of that, and main code, nobody's going to change it. We all will check out the code, and we create a branch according to the project name, and we create a uh, branch according to the module or feature that you're working on, and you will check in into only that particular piece of branch. At the end of the day, again, you will check in into the main code. But like if multiple people are working on the same package or same file at same time, and when you both are trying to checking into it, the merge and taking care of all the conflicts and everything is automatically taken care by your version control system. So when I say conflict and merge, suppose there is a testng.xml file. I hope you all will be able to relate it now. Suppose we, as a both automation engineers, we are opening the same testng.xml file, and you are editing some portion for your requirement, and I am editing some portion of the requirement for my need. And we both are checking into the version control system, the Git or GitHub at same time. So this system is smart or intelligent to identify there is one change coming from me and one change coming from you. Let's say I did a change of 2 lines of code after 13th, which is 14th and 15th. You did a change of code like at the 9th and 10th line of code. So what it does is it will identify these two are two different changes coming in, and it will try to merge these two into the file. And basically it's a conflict. First of all, same file being changed. So then it will be able to merge it and automatically put the both the changes into the version control system. So that is what is meant by conflicting and merging. So we'll see all that practically part of the Git and GitHub session. So definitely, be it a developer code or be it an automation code, we need to maintain it centrally so that all the people can access it. So let's focus on the developer code for a minute. So assume that this is a developer's code here. So code is being maintained, okay, in the version control system like Git or GitHub. Now, let's assume every day they have decided, so they want to have a daily deployments. Okay, the project team has been decided that they want to have a daily deployments. So there are different developers working from different locations, as I told you. So they all will check in the code into this version control system. There may be a cutoff time saying, let's say 6 p.m. Just giving some time. Do not take it so hard, like, let's say 6 p.m. PST is a cutoff time for submitting the code that has been decided for this version control system, considering a lot of developers are from on the PST side. So what this tool will do is we will create a build script as part of our continuous integration and continuous deployment script. We'll create step one. So step one, what I'm doing is we will create an automated script or an automation code that will check out the code from this version control system. So what it does is it will check out the code from this version control system and it will try to compile this code. Let's assume for a simple understanding, it's all Java code. So in one of the server or in one of the central system, we schedule this script. It could be something like a shell script, or it could be something like a JavaScript. So we in the sense do not assume all from QA. Part of this is a combined activity from developers, QA, and the operations team. All have to come together. Then only the CI/CD is possible. Okay. So either the operations team or development team will create a script, and this script will be scheduled. So script is scheduled. It is scheduled to run at, let's say, 6:30 p.m. Okay, it's scheduled to run at 6:30 p.m. So where do we schedule this? That's what we're going to learn in a tool called Jenkins. So we're going to understand a very important tool called Jenkins. Even we will schedule our automation script there and see it will automatically execute and all that. So we're going to schedule it in a tool called Jenkins, and it will start automatically at 6:30 p.m. We'll check out the latest code, whatever the latest code available in the version control system, and it will start compiling it. While compiling it, there could be many different issues that might come up. Let's take, as we all familiar with Selenium, so let's take an example of a Java code. And we all know in the world of Java, it's all through jar files, right? So let's say some developer has written a code or an automation test engineer has written some code and he has checked into it. And while compiling it, one of the jar file is missing or one of the jar file is not the latest one. So we are getting into the issues of compilation. So to take care of that, especially which jar file should be available, which version of the jar file should be available, and to maintain a proper project structure, we are going to develop or we're going to understand a very important tool called Maven. So which is also part of our CI/CD discussion. This is from an organization called Apache Maven tool. So we call it as a build management tool. Generally, people call it as a build management tool or a project management tool. Apache maintains a proper project structure, like where we should maintain our uh, main development code, where we should maintain our test cases, and what are the different jar files that we need to run the project. We're going to add them into an XML file. So we're going to see all that very detailed in as part of these sessions. So there will be something called pom.xml. In the pom.xml file, we're going to maintain all the jar files with its versions. So even if any jar file is not available in your project while compiling it, it will automatically download that jar file. So there is a Maven repository in which all these jar files are maintained. Every single jar file will be available in that. So it will download from that and make it available to your project. So the chances of getting the issues at the time of compilation because of these jar file dependencies will be very, very less if we create our project into Maven. So most of the Java people, most of the Java projects are going to be using this Apache Maven and going to be taking care of the benefits of this particular dependencies things. Is this clear why? I mean, just like you should be very high level, you should get an idea of these individual tools, why we are going to use version control system, why we are going to use Apache Maven, and why we are going to use Jenkins, and the whole picture of the CICD. So that's the target for today. So do let me know if you have any questions in between. So to take care of the Java jar file dependencies and creating a proper project structure, we're going to use Apache Maven. So let's assume we are using that, and obviously the issues will be very, very less at the time of compilation because we are taking care of all those dependencies. But still there can be chances of your code not gets compiled for various reasons. Ideally, if it is a full-fledged implemented CI/CD project, around the clock there will be an operations team available 24/7 who will be monitoring these process. And if anything that gets failed at the time of compilation, the operations team will get a notification or email or an alert immediately saying, your compilation of today's project has been failed, and here is the reason for the failure. And today, you might have even heard about something called DevOps. So that is where they are working. So I'll explain what used to happen previously and what they're planning to achieve today. Previously, what used to happen when an issue comes to the operations team, they will look at it at a very high level. And if most of the operations team may or may not be very comfortable in fixing the issue, so what they're going to do is they're going to write an email to the developer or owner of this particular code which is getting failed, or send a instant message. If he or she is not available, call them up, whatever the timeline is, call them up and explain, hey, your code is failing. It's part of the compilation process today. And that person needs to wake up and fix, even if it is a midnight for him, because it's a daily job, and there are customers or users are going to wait for this build in the next day morning. So we're going to wake that person and explain the situation, why is it failing, and the person has to wake up and fix this issue immediately. Otherwise, the whole chain is going to block, whole process is going to block. But that's actually creating a lot of problems in the work-life balance of the developers as well as both operations team, or even it's actually time consuming and it is delaying the process. So that's why they are coming up with a new model called DevOps model. Most of the companies have already implemented, or people trying to implement, is that in DevOps, the developer, while developing the code itself, he has to take care of the whole operation scenarios, what operations team is going to work and how they're going to manage their builds and how they're going to do the deployments and everything. Considering that he has to write the code, he should be totally aware of the what is happening on the operations side. Operations team should totally aware of development. If there is an issue comes, without waking up the corresponding developer, he should be able to fix on his own. He should be able to fix it by his own, so that the time will be saved, and the other person doesn't need to really wake up and come online and fix issue. So that is where the industry is going into the model of DevOps. It's like developers and operations team coming together, or trying to know each other areas, and if required, code each other areas. For example, mainly the shell script, Python script, and all that operations team used to do. Now the developer have to be completely aware of that and do the scripting if required from a deployment point of view also. So let's assume that was a scenario. So if the compilation fails previously, They used to call the corresponding owner, or mail or instant message, and he used to command line and fix it. Now with the DevOps, the operations team should be able to take care of themselves. So any questions in the first step? The first step is very simple. Check out the latest code. And this is mostly like a shell script scheduled in a Jenkins. And who will own the first part? The first part will be owned by, I can safely say now, DevOps team. I don't know whether it's a developer will own it or operations team will own it. That's fine. It's a DevOps team that will own it. Now the first step is to check out the code and compile it. Then comes the second step, which is basically, so after compiling, what will happen? You will get some jar files or var files in case of Java, right? Either they may be .jar or they may be .var files. The next important step is installing or deploying these into the corresponding server, right? The next step is deployment. The latest bits have to be deployed onto the corresponding server. And in a project, typically what will happen, these are the different servers. The development team will write the code and do the unit testing in development environment. We all know that. So there will be a development environment in which the developers will write the code and unit testing. After that, we will have a SIT environment, system integration testing environment. This is where the QA will perform the integration testing and system testing or end-to-end testing. But this code needs to be, somebody needs to deploy this code into this SIT environment. That is through this particular step, which I'm talking about. The second step is about build deployment. Who will do that? Typically, in most of the organizations, the operations team takes care of that. Or deployment, we also call them as deployment team. So I would say this is about build script. So you can simply call it as the second step is about build script or deployment script. Again, this could be command line code with some shell script or JavaScript or Python kind of a script. And let's assume this compilation runs at 6:30 p.m. So this might be scheduled at some 7:30 p.m. Assuming this process, compilation of the process will go for half an hour, we'll give a half an hour gap, and at 7:30 p.m. this deployment script will start. Okay, let's continue this discussion on the environment. So after you done with the SIT, either you do manually or you do automation script, and part of the CI/CD automation. After you run your regression suite, first you'll actually run something called sanity suite or a smoke test. After that, you'll do regression test, and then you do some manual testing as well if required. Then you will sign off, and then the latest code needs to be deployed it into something called UAT environment, user acceptance testing environment. This is where the actual users of the system will come into picture, and they will do user acceptance testing. And they are going to do in two ways, manually, and nowadays the users are also smart and they are also doing an automation. As part of this, again, even though it's a CI/CD, you will get to learn uh, two more concepts, which is like, at the end of these tools, it's totally free of cost, is that we're going to understand what is something called test-driven development, acceptance test-driven development, and we're going to understand, more importantly, behavior-driven development. All these are some sort of examples of UAT where the users will do. TDD is totally from a test point of view, it's from a QA point of view. But ATDD and BDD is majorly from a user's point of view. So we're going to understand one of the important tool for the BDD is called Cucumber. So we're going to learn that tool as well. as part of this. So nowadays, what users are doing as part of their user acceptance testing is that they will create some sort of feature file how they wanted to test it, and we as a QA will convert that into a Selenium script. And so they're going to use that Selenium script and perform user acceptance testing. So user acceptance testing will be done by the users in the UAT environment, and we want all this to go in a continuous fashion. No, Cucumber is, we call it for behavior driven development. So it's not for UAT. We'll even start using it at the time of development itself. But ultimately, if it is developed, they can use it for UAT also. In a way, to answer your question, Lakshmi, like it has to start from the development time itself. It's not just for UAT. It has to start from develop. It's one of the development methodology itself. But once the script is ready, they can use it for UAT. Okay. So this is how the users are going to perform. And if they are comfortable and if they say, yes, it's working, the next step is to deploy it into production, right? So the next step, what we're going to do is we're going to deploy it into production. And in a way, the whole thing which I'm talking about, this whole chain of thing, we call it as a pipeline actually. This whole pipeline process should be automated from deploying it into development environment to, and after they run some unit test or unit scripts automatically, then system should automatically deploy into the SIT environment, and after the QA runs some regression test and confirms it's working fine, it should be deployed in UAT environment, and after the users run some automation scripts or maybe their Cucumber scripts and confirm it's working fine, it has to be deployed into production. So this whole pipeline should be automated. This whole uh, process of moving from one environment to the other environment should be automated, and that whole process is called pipeline. And what we're going to learn part of this is that basically how we can create all these scripts and how we can create this whole CI/CD pipeline. So don't get confused. People call it a CI/CD, people call it as a pipeline. So anything's fine. So just coming back over here, first step is to compile the script and generate the jar file or WAR files. The second step is to create a build script to deploy it into the required environment. Maybe this is to deploy it in SIT or to deploy it in UAT or to deploy it in production. So according to the sequence that is being configured, it's going to deploy there. So this is again, who owns this? Again, this is also DevOps. Both first step and second step will be owned by the DevOps team. Now comes the QA part. So let's assume this is being deployed in SIT. Assume that it is being deployed into SIT environment. So the question naturally comes where we started was how you're going to run your regression suite. So pipeline is automated using CI/CD tool, correct? So now what we're going to do is how we are going to run these automation scripts. So that is the next step. So the next step is kick off automation scripts, whether it is a simple BVT test, sanity test, or it could be your automation suite that you have developed with some framework and couple of test cases, maybe something like a regression suite. And this you might schedule at around 8:30 p.m., assuming that the deployment process will go for half an hour to 1 hour. So you'll schedule it around 8:30 p.m. And this is purely our responsibility. So this is QA responsibility. Okay, so this is what we're going to see practically. I might not show the step 1 and step 2, but I will definitely show where you're going to configure the script, how you can make it as. So in a way, in this whole pipeline, what is happening is for step 2, this is a prerequisite. Unless step 1 completes, you cannot start step 2. Even though you're scheduling it 7:30, We don't need to schedule it time. What we can do is we can schedule it like to start step 2. The prerequisite is step 1 should be successfully completed. Only with step 1 successfully completes, we'll start with step 2. And after step 2 successfully completes, we will start step 3, which is basically kickoff automation script. So what we are going to do over here is that we are going to run our regression suite. Run the regression suite. And this will launch all the 60 or 70 test cases that you have automated. It will try to perform the regression testing on your application and will ensure, the latest code or impact analysis. According to the impact analysis, whatever you have automated, that is all being tested and ensure it gets successful or non-successful, whatever the results according to that. Once the regression suite gets confirmed, then again deployment script will come into picture. That is this step. Almost the same step gets repeated, but for a different environment. Now it is going to happen UAT deployment. So this time it's going to be a UAT deployment. Here it is more like a ST deployment. So then it's going to do it in UAT deployment. Because our regression suite is successfully completed and it send out a notification, we will see how to configure email. We'll also send out the emails. So that email will tell you the entire regression suite is completed and it's kind of ready for UAT deployment. So that's when the fourth script will come into picture, and this fourth script is going to deploy it into UAT environment. Again, some sort of a script, deployment script. And this is going to deploy it in UAT environment. Again, it will send out a notification to the DevOps team as well as for QA and main importantly for users saying the today's latest build, which is developed by so-and-so development team. Is it step 4 run if it? No, so that's what these are all tightly coupled with one another. If one fails, the other one will not move forward. And the corresponding people will receive the notification of failure. And it is a DevOps team's responsibility. If it is automation fails, QA team responsibility to come online and fix it so that the next pipeline will continue. Otherwise, the whole pipeline is break now. It's kind of broken. And if you look at some of the major companies, right, Facebook, Amazon, Netflix, this kind of process happens multiple times in a day, not even once in a day. And it's all through automated process. Yeah, to answer your question, Lakshmi, like it won't start the regression. It is like pipeline is blocked and the corresponding person should come online and fix it. So the script is going to deploy it into UAT environment and the corresponding UAT owners will receive a notification saying the deployment has been successful and it's ready for UAT. So then they will have developed some UAT scripts, maybe in the form of a behavior-driven development through Cucumber. Or if they are comfortable, let's assume some companies what they do, they develop a keyword-driven framework and they are going to simply, the users are going to simply write a Selenium scripts based on the keywords, or it could be Cucumber script. So they are going to run the UAT tests. They would have automated some 30, 40 out of 100 as part of their UAT. So they're going to run. So what is the fifth step? Fifth step is basically kickoff UAT tests. Or for our simple understanding, let's say kickoff Cucumber tests or UAT tests, whatever is fine. So that's why we are going to discuss even Cucumber as well as part of this, even though I mean it's useful because there are some companies who are actually implementing Cucumber behavior driven development. So we'll talk about that. And if the UAT gets successful, then we will have the last final step. We don't write Cucumber scripts, right? So when I say Cucumber, okay, so Cucumber has its own structure. The very first thing is to write a feature file. That feature file is owned by, you're right, but I'm just trying to elaborate the point. The feature file is written by the users in a simple English Gherkin language. So the Gherkin language will have some simple commands like given, when, and then kind of commands. So given the condition, when user performs this, then this is the result. So they're going to write some simple English language commands, and that is written by the UAT team, that is written by the users. And what we do as an automation QA, we take that feature file and we'll convert that into Selenium script. According to the Gherkin language commands, they have done it. In fact, Cucumber has that capacity of reading all the lines and creating the corresponding methods in Selenium WebDriver. And we are going to fill that WebDriver methods with the corresponding steps. Like, it has to open the website and it has to do these things, and then this is expected behavior. So it's almost like they write the test case in a simple English language. They, in the sense, the users, that is feature file, and that feature file will be converted into the automation script by the QA team. So, but if you say the general statement like, what did you say previously? We don't write Cucumber scripts. That's not correct. Cucumber we write, obviously, but only feature file we don't write. Feature file is written by the users team. The Cucumber script is obviously we have to write it. All right, so we'll see anyway. So we have sessions on that. We'll see practically. So don't worry about that now. So after the UAT scripts is done, then we will have a deployment into production. So the last step is production deployment. Even this is automated through some script again. Which is going to run only when the fifth step is successful. Fifth step will run only when the fourth step is successful. Fourth step will be run only when third step is successful. So like that, it's purely coupled with the previous step. And that's why this whole process is called pipeline or continuous integration, continuous deployment. So this is the picture, whole picture of it. And in this, it's not everything that QA team will own. Mainly QA team owns running the regression suite, running the UAT scripts suite, maybe if the users are not very technical and if they expect you to help it. But other than that, the remaining steps are owned by the DevOps team. So I would start calling as DevOps team. Either the developer or operations team will own it. But the remaining, the running of the regression suite is definitely owned by QA. But these are all tightly coupled. And how we are going to do all these things, we're going to do it in a tool called Jenkins. So that's where we're going to understand how do we schedule the jobs in Jenkins. How do we make this as a pre-step and a post-step? How do we configure the emails in such a way that if any step fails, the corresponding owners will receive the email? And to minimize the failures at the time of compilation with the help of especially with the issues related to the jar files dependencies, we are going to learn this Apache Maven tool first, and then we'll look at Jenkins. But the more importantly, how do we maintain the code? Because even you as an automation engineer, you would have developed some regression code. How do you maintain that code in a version control system like Git and GitHub? So we're going to learn Git and GitHub. So typically this will be about 4 sessions, right from command prompts to the central GitHub. Then we will have about 2 to 3 sessions on Maven and 2 to 3 sessions on Jenkins. Then we are going to spend about around 5 sessions on Cucumber. to understand the whole BDD process, behavior driven development. Yep, this is what we're going to learn as part of this CICD tools. It is definitely not sufficient if you know only Selenium WebDriver, and if you are even an expert in automating the test cases, even if you have developed a framework like a DDF or a KDF or page object model, you need to know all these things, because in today's world, the interviews will directly start with this actually. Almost every company has a target of implementing this. Some are already successfully implemented and running it on a daily basis. Some companies running it on a weekly basis. Some companies are running it multiple times in a single day. So all these are already there. So any questions on the overall CI/CD or any of these tools, what we're going to learn and why we should learn? So we'll spend the next 10 minutes in taking up the questions. Happy to help in case of you have any questions. But who you got an idea? We're going to learn Apache Maven, Jenkins, GitHub, and Cucumber. Of course, we are even going to talk about the test-driven development, acceptance test-driven development, behavior-driven development, which I have not covered in my Selenium course as well. We're going to talk about something called robot framework also. Like we'll spend about 2 sessions on robot framework. That's also kind of important. So totally, these are the tools we're going to learn it. Okay, the first deployment is the SIT deployment, and other is UAT. Yes, so it starts in this sequence, right? You can see here. First, developers will write the code and they will do unit testing. So okay, what is another thing that happens, right? When the developers write the code and when it gets compiled successfully, the most important thing, the first thing that will run is unit test scripts. Even developers are writing unit test scripts, and they are also scheduling the unit testing scripts. They also want to do, I mean, it's very important that the development team has to do unit testing, right? And they don't want to do manually. So that's where they're going to use JUnit, and their JUnit scripts will be run automatically. That is the first script. First step, only when their unit testing successfully completes, they will deploy it into SIT. So between compiling and deployment into SIT, we can add one more step called unit test script, JUnit scripts. So they would have also automated some 20, 30 test cases at every unit level. That will run first. Only when that gets successful, they'll deploy it into SIT. And if the SIT deployment is successful, our WebDriver scripts will run. And if WebDriver scripts get successful, then we'll deploy it in UAT. If the UAT deployment is successful, we'll run Cucumber scripts. If that gets successful, then we will have production deployment. So hope this is clear now, Piyush. So I just missed one important thing, which is also very, very important. That is unit test. All right. So any other questions that you guys have? So having only the Selenium knowledge won't be really sufficient. You need to have this. So in my interviews, I'll directly start with this. So what is CICD? Do you have an experience of implementing it? If he says yes, so can you explain me how you generally do it? If somebody brings up a little bit of knowledge of I did this, and then I'll ask questions on Jenkins. The question is like, they're all independent, so not really a sequence. Ideally, yes, we should start with GitHub and then we should go. But I'll do slightly different. So we'll start with Maven. We'll look at Jenkins also, because GitHub is an independent tool. So whether you do with automation, don't do with automation, you have to know this version control tool. So I can start in any way. I'm not really made up my mind, but we can start it anyway. So yes, GitHub, finally you have to know it. So don't worry on the order. Given in any order, you have to, all these things you have to put it together and stitch it together, then it will become CICD. Learning it in any order is not important while learning. All right. Any other questions? And a lot of people are trying to achieve this. And it takes a good amount of time. It's not just from QA side. It's all dev, QA, ops. Everybody should come together, and everybody should no. We will have about one on TTT, one on ATTT, and Cucumber will be around 3 to 4 sessions. So totally like 5 sessions on this. Acceptance tester driven development. So TDD stands for test driven development. So what happens in test driven development is, because the testers are able to think through the features better than the developers, this methodology came into picture. So when a new requirement comes, first testers will write the test cases. More specifically, we'll think about negative test cases which will fail. Positive test cases, even developer will think, right? So we'll use our testing skills, QA skills, think negatively and identify negative test cases. Obviously, when the negative test case is given to the developer, he would have not thought through while writing the code. So his code will fail, and then he will actually implement the solution for that negative test case. So that's why it's called test-driven development. And we can automate that, yes. So that is from there. Why should we stop only a tester? Why can't we involve user at the beginning and ask him to come up with the acceptance test cases, how he's going to accept the system? Then according to that, the testers will write positive, negative test cases. According to that, the developer will actually do the development. So totally coming in the reverse order. Previously, how it used to happen? First, developers will write the code, then testers will test, then acceptance test team will test. Now totally we reverse the order. First, acceptance test team will write the cases, then the QA team will write detailed positive, negative test cases, then the development team will develop it. Okay, that is called ATDD, acceptance test driven development. Then a new methodology came into picture called BDD. So this is more like how a user really behaves when he is using the system. So capture those behaviors. For example, you as a user, you go to an ATM machine. What are the different behaviors you exhibit when you are in the ATM machine? Like how do you insert a card? What are the different options you would expect? So that behaviors, considering the behaviors, the methodology came into picture called behavior driven development. All right, so yeah, user point of view, correct. And this robot framework is as simple as keyword driven framework. But people who attended my sessions, like we developed a keyword driven framework and we had to write good amount of code. And when you go to robot framework, you don't need to write any code. It uses the Selenium 2 library, and it's a simple grid will be displayed for you, and you have to just choose the keyword and write your script. So it's already implemented keyword driven framework kind of a tool. But we'll touch upon that as well, so that it will be in case if somebody wants to start automating from the day one of your project, you can use robot framework, which is again an open source. All right, so these are the tools. I'm just reiterating again. We're going to talk about Apache Maven, Jenkins, GitHub, TTD, ATDD, BDD, Cucumber, robot framework. These are all part of the sessions, which will take about 12 to 15 sessions, 12 sessions minimum, and 15 sessions maximum. All right, so hope you got a picture of what is CICD. Thanks for attending the session, and we have a data-driven framework implementation session 5 minutes from now, done by Karthik. So if you guys are planning to attend, feel free to attend there. Yeah, otherwise, we'll continue the CICD. So we'll send out an email with the exact date and time, and we'll start from the session 1 there. All right. Thanks, everyone. Thank you for attending this. Thank you.